When we picture a planet, we almost always picture it circling a star, right? Just like our own Earth. But what if I told you that our galaxy is hiding a massive population of worlds, maybe even trillions of them, that have no sun, no star to call their own? These are the galaxy's lonely wanderers, and they challenge everything we thought we knew about planets.
Just let that sink in for a moment. Imagine a world with no sunrise, no sunsets, no seasons, no year. It's just a solitary world, sailing through the endless, silent dark between the stars. It's a hauntingly beautiful idea, and it perfectly captures the mystery we're diving into.
So, what exactly are we talking about here? Well, the official term is a rogue planet, or a free-floating planet. And it's pretty simple, really. It's an object that has the mass of a planet, it's got the right size, the right heft, but it's completely on its own. It's not gravitationally tied to any star. It's a true cosmic nomad.
Now, you might be thinking, okay, so there are a few celestial weirdos out there. But no, this isn't just a handful of oddities. We're starting to realize that these starless worlds are actually a huge and super mysterious part of our Milky Way galaxy. Here's the big problem for astronomers, though. A rogue planet is incredibly cold. And since there's no starlight around, there's nothing for it to reflect. So if you're looking with a regular telescope, they are completely, totally invisible. The only tiny clue we have is a faint glow in the infrared spectrum, which is basically leftover heat from when they formed billions of years ago. So, if you can't see them, how in the world do you find them? Well, this is where the story gets really fun. It's like a cosmic detective case, and astronomers had to get incredibly clever to hunt for these invisible ghost worlds. I mean, that's the central question, isn't it? It's like trying to spot a black cat in a coal cellar at midnight. Your standard tools, your telescopes, they're just not going to work. You need a completely different approach. And the answer they came up with is just brilliant. It actually comes from an idea that Albert Einstein himself predicted. Instead of looking for the planet's light, which is practically non-existent, they look for its gravity. They literally use the planet's own mass as a giant cosmic magnifying glass. The technique is called gravitational microlensing. Here's how it works. Imagine a rogue planet happens to pass perfectly in front of a much more distant star, from our point of view. The rogue planet's gravity is strong enough to actually bend space-time around it. This warp acts like a lens, bending the light from the background star and focusing it right toward us. So for a few hours or maybe a few days, that distant star appears to get brighter, and then it fades back to normal. That little flicker is the signature of an invisible planet passing by.
And this isn't just a theory, it really works. Back in 2020, a survey called OGLE used this exact technique to find a rogue planet with a mass somewhere between Mars and Earth. Just think about that for a second. We found a small, rocky world, maybe even like our own, drifting all alone in the dark, thousands of light years away, just by seeing the tiny little wobble its gravity caused in starlight. It's amazing.
Okay, so we know they're out there, and we've got this super clever way to find them. The next big question is pretty obvious. Where did they come from? I mean, how does a planet end up all alone in the first place? Turns out there are two main theories. So you've got two main possibilities. The first is the ejection scenario. In this story, a planet forms totally normally around a star. But the early solar system is a chaotic place. Things are flying all over, and a gravitational tug of war, like a game of cosmic billiards, violently flings the planet out into deep space. It becomes a planetary orphan. The other idea is the isolation scenario, where the planet forms all by itself out of a collapsing cloud of gas and dust. Kind of like a tiny star that just never got big enough to ignite. It was a loner from birth.
For a long time, scientists have been debating which of these stories is more common. Was it ejection or isolation? But very recently, we got a game-changing clue that points really strongly toward the isolation idea. And it comes in the form of something with a great name: jumbos.
In 2023, the James Webb Space Telescope was looking deep into the Orion Nebula, and it spotted something just jaw-dropping. It found pairs of Jupiter-sized planets that were orbiting each other with no star anywhere in sight. They called them jumbos for Jupiter mass binary objects. Now, here's why this is such a big deal. A violent ejection from a solar system would almost certainly rip a pair of planets like that apart. The fact that they're still together strongly suggests they must have formed together, all on their own, right where we see them.
All right, so these worlds are cold, they're dark, they're lonely. They honestly sound like the most miserable, inhospitable places in the entire universe. But hang on, because this is where the story takes a really fascinating and completely unexpected turn. It seems like a crazy question, right? I mean, every model for life that we can imagine is based on getting energy from a star. Without a sun, you'd think a world would just be a dead, frozen ball of ice and rock forever. But nature might just be a little more creative than we give it credit for. You see, the key to life might not be external heat coming from a star, but internal heat being generated by the planet itself. Even without a sun, a big enough planet isn't necessarily geologically dead. It can have its own furnace burning deep down inside.
So where does this heat come from? Well, a few different places. First, you've got leftover heat from when the planet first formed. Second, the decay of radioactive elements deep in a rocky core can act like a slow-burning nuclear reactor for billions of years. And finally, if that rogue planet has a moon, the constant gravitational tug-of-war between them could generate enormous amounts of heat from friction. That's called tidal heating, and we see it happening on moons in our own solar system. Now, this raises a mind-blowing possibility. All of that internal heat, trapped beneath a thick, insulating shell of ice, could be enough to keep a vast, global ocean of liquid water from freezing. We think life on Earth might have started around geothermal vents on the pitch-black ocean floor. Who's to say the same thing couldn't happen on a rogue planet powered entirely by its own internal heat?
So, this brings us to the final and maybe the most staggering part of this whole story. We've talked about what these worlds are and what they could be like. But now let's zoom out and just try to comprehend how many of them might actually be out there.
Okay, brace yourself for this statistic because it is truly wild. Based on the microlensing surveys we've done so far, astronomers now estimate that for every single star in our galaxy, there could be as many as 6 rogue planets. They aren't rare, they are unbelievably common.
To put that into perspective, just look at these numbers. We think there are about 400 billion stars in the Milky Way. Well, the number of rogue planets could be over 2 trillion. If these estimates are right, it would make them by far the most numerous type of planet in the entire galaxy. And our knowledge about all this is about to just explode. In 2027, NASA is launching the Nancy Grace Roman Space Telescope. One of its main jobs is to do a huge microlensing survey that is expected to find hundreds, maybe even thousands of these wanderers. It's going to give us our first real census of this invisible population. So the big takeaway here is really a fundamental shift in how we see the cosmos. For pretty much all of human history, we've thought of planets as things that belong to stars. But it's starting to look like the most typical kind of planet in our galaxy might be the one that travels completely alone. And that leaves us with this one last profound thought. If there are trillions of these worlds out there, and if even a tiny fraction of them have warm, liquid oceans buried deep beneath the ice, could it be that the most common homes for life in our galaxy aren't sunlit worlds like ours, but are instead hidden away, thriving in the endless, eternal darkness?